Good morning, everyone. It is Monday, September 22nd, and we're going to get started with class by doing our bell work, right? So first thing you need to have is this paper in front of you, right? We are going to be working on the Monday question, right? I'm going to read it to you, and then I'm going to pause and give you a couple of minutes to finish this question. Double check that you also justify it, right? I just have mine covered up, right? So it says, Monday, a group of students were discussing their lab results after conducting an investigation on metals, nonmetals, metalloids, and rare earth elements. This is what they said. Zeke, rare earth elements are metallic and used in many different technologies. Chandra, carbon is an example of a metal because it is dull and a poor conductor. Alyssa, malleability describes the ability to be pounded into thin sheets with a hammer. Nonmetals are malleable. Diego, potassium is a nonmetal because it is shiny and ductile. Based on their discussion, who is correct? A, Zeke, B, Chandra, C, Alyssa, D, Diego. Right, answer your question and justify it. If you need to use your notes, use your notes. Alright, we are back and we're going to answer this question. Make sure if you got it wrong that you are fixing your answer, but hopefully this is review, right? Because we learned this all last week, so you should know this. Right, so let's go through answers one by one. Let's start with Zeke. Right, he said rare earth elements are metallic. Right, metallic is another word for shiny. Right, if you got that confused, right, there we go. Metallic is shiny. And it's used in many different technologies, right? Based on what we know about rare earth elements, right? Rare earth elements are also called rare earth metals. So based on what we know about metals, metals are shiny, and rare earth elements, they are used in technology, right? So far, that seems pretty right. Right, next, Chandra, she said carbon is an example of a metal, right, because it is dull and a poor conductor, right. First of all, right, carbon on the periodic table is not a metal. Mine's not completely done, right, but carbon is over here in the yellow, right, so that is a non-metal, right, so that's not correct. Right? And it says metals are dull and poor conductors. That does not make sense either. Right? Those two do describe carbon, but metal is wrong. So let's rule out that. Chandra was not correct. Malleability describes the ability to be pounded into thin sheets with a hammer. Right? All of that is correct, right? About how you can bend it. Right? Nonmetals are malleable. Well, that's not true, right? They are brittle, right? So Alyssa can't be right. Sorry, excuse the bell. Right, and last one, Diego said potassium is a nonmetal because it is shiny and ductile. Right? Well, nonmetals are not shiny, right? They are dull. And ductile kind of goes with malleability. Right, so.
Good morning, warriors.
Alright, sorry, I had to pause it for announcements, right? Like I was saying, right, so we know that nonmetals are dull, and ductile, remember, it has to do with malleability, right? So they're not ductile, they're not malleable, they would be brittle. So that one also doesn't make sense, okay? So we're down to one. A was our correct answer. Zeke was the only one that was correct. Here's my justification. Right, I said rare earth elements are usually shiny and used in technology. Right, that's a great justification. Right, so pause this for a second, make sure everyone got it. Right, now we're going to be moving on to our next thing for today. Right, we are starting something new today. The new thing that we're going to be starting is over chemical changes. Right, so the first thing we're going to go over is our vocabulary. Right, so I'm going to pause this and get vocabulary up on my screen, and I will be back in just a second. All right, I finally got it up. All right, so we're talking about chemical changes, which has to do with the formation of a new substance. All right, so we have some vocabulary to go over. All right, first we have what is a chemical change. All right, a chemical change involves one substance either being pulled apart or combined with something else to form a completely different substance. Right? So a chemical change is something new being formed, right? And there's a couple of different ways we can tell if something has undergone a chemical change, right? This is not like a physical change like you've talked about in science before, right? Like if you took a piece of paper, right, and you ripped it, right? It's still paper, right? This is something completely different, right? This is like if I took this piece of paper and I lit it on fire. I'm not going to do that, right? But if I lit it on fire, right, it would burn and it would create ash, right? And it would create some smoke, right? And that is a new thing being formed, right? So this is a chemical change, something new, right? Some different ways we can tell if something has undergone a chemical change is a color change. Right? A color change, right, is a change in the way something reflects light, right? So, for example, this pumpkin right here, right? This is a pumpkin that is rotting, right? There is mold, there are spots all over it, right? But you can see that it has turned like a dark color, right? Black, gray, right? All over this orange pumpkin, right? That is a change in color. So something new has been formed, right? You'll also see right, I'm going to come back to gas, right? Sometimes something called a precipitate is formed, right? Everyone say precipitate. Precipitate, right? A precipitate is an insoluble solid, right? Formed from a chemical reaction, right? So all that is fancy in saying, right? You mix two liquids together and it makes chunks. Right? A precipitate is just like chunks being formed, right? So they mix this blue liquid with whatever this clear liquid is, and when they mixed it, it formed this solid that's not dissolving in the two liquids, right? That's what insoluble means. So there's chunks formed from two different liquids, right? Sometimes you'll also see a change in thermal energy, right? You should know from 5th grade that thermal energy stands for like heat energy, right? So you can see right here, right, we have a solid forming into a liquid because heat was added, right? And then heat was added and it turned into a gas, right? And then it cooled down, same thing this direction, right? So when something is cooling down, thermal energy is lost. When something's heating up, thermal energy is gained, right? So thermal energy, right? This has to do when a chemical reaction happens and either it gets hot or it gets cold, right? This happens sometimes, right? Later in the week, I'll get to show you one that you'll actually get to feel it get really cold, right? So thermal energy, it can either get hot or it can get cold. That's a key that something new is happening, right? Like I told you I was going to come back to gas. Right? When we have a chemical reaction and a gas is formed, usually we can see it because it starts bubbling, right? So we know what gas is, right? I want you to think about if you have ever done baking soda and vinegar mixed together, right? What happens? Well, when you mix the vinegar into the baking soda, right, it starts to bubble, it starts to foam, right? That tells us that it's producing gas. It's making gas. And that is a piece of evidence that a chemical change has occurred, right? So when you see production of gas, think bubbles, right? Right, so those are all of our vocabulary words, right? I'm going to pause and I'm going to come back, right? And I need everyone to have this paper when I come back. Chemical changes notes. All right, we're back. Right, so everyone has this paper in front of them. Make sure you put your name up at the top. This is going to go in your binder when we finish. Right, so we're going to take our notes. Right, we just talked about these things, right, and now we're going to write some stuff about them. Right, so we talked about chemical changes when something new is formed, right? There's 4 different pieces of evidence that we look for, right? The first is temperature change. On our vocabulary, I called this thermal energy change, right? That's the same thing, okay? So a temperature change, right? First, blank right here. Anything I write, you need to be writing too, right? A temperature change temperature changes can indicate the formation of a new substance. Something new is being formed. There's 2 different types of temperature changes. Right? We have some fancy words for them. We have exothermic, which is a reaction that produces heat, making or releasing energy. Exothermic reactions make substances warmer, right? I want you to underline produce heat, warmer, right? They are making heat. Right, next we have an endothermic. Reaction. Right, these absorb heat by absorbing energy. Right, because we talked about this as thermal energy. Right, they absorb energy and they make things cooler. Underline those 2 words for me too, please. Right, so some examples of this, right? Has anyone ever had a hand warmer? They're a little pouch, right? And when you take them out of the plastic, the chemicals inside of the pouch react with the oxygen in the air, and it produces heat. It makes it warm. So if you're ever out in the cold, if you're at a football game or something like that, and it's cold outside, right, you can put that in your pocket and it keeps your hands warm, right? So hand warmer, it produces heat, right? So that would be an example of an exothermic reaction, right? Another one that I talked about earlier is baking soda and plus vinegar. Right, we're going to do this later this week and you're going to be able to feel it, right? So when you mix baking soda and vinegar, not only does it bubble, right, production of gas, that's what I was talking about earlier, it also absorbs energy and it gets cold, right? So we're going to be able to feel that. That's going to be an example of an endothermic reaction, okay? So there's 2 examples for you. All right, now we're going to move on to production of a precipitate. Right, I hadn't even thought I should probably zoom in a little bit. Right, anytime you need to pause this to make sure we're getting everything down, that is totally fine. Right, so production of a precipitate. Right, a precipitate is formed when substances are mixed together and a solid is formed. When 2 substances are mixed together and a precipitate is formed, it is evidence of a chemical change. Something new is being formed. Right, so there's 2 examples of this that I have, right? They're really gross, right? But if you've ever mixed Coke and milk, if you let it sit for a little while, it curdles and makes chunks, right? So it forms a precipitate, 2 liquids forming a solid, It's really gross. You can also do this with milk and vinegar or some other type of acid. Right? I have to do this when I am baking and it asks for buttermilk. So buttermilk is actually this reaction that happens right here between milk and an acid, right? And it kind of makes it sour, right? But if you put too much vinegar and acid, it'll curdle the milk and it'll make chunks, right? So really gross, right? But something new is being formed with the chunks of a precipitate. Right, pause that if we need to. We're going to go down to production of gas. Right, I'm going to zoom in a lot right here. Right, so a production of a gas is when a gas is produced. It's evidence of a new substance being formed. Often you can see the gas being formed when the substances begin bubbling. Right? We talked about this just a second ago in vocabulary. Gas equals bubbles. Right? You could also see gas in another way, right? Like when you burn wood in a campfire in your fireplace, right? It produces smoke, right? And that is a gas. Right? Our other example of this earlier was baking soda. And vinegar. Right? So gas could be bubbles, it could also be smoke. Right? Pause that if we need to. Last one is an unexpected color change, right? So unexpected is really important. I want you to underline it, right? If it's a color change that you expect, it is not a new substance. For example, right, if you take water and you add food coloring, right, you're expecting the color to change because you added the food coloring to it. Right? That is not a chemical change. That's a physical change. Right? An unexpected color change, right, is when you mix maybe two clear liquids together and they turn green. Right? That would be unexpected. Right? You expected the clear liquid and the clear liquid to make a clear liquid, but instead it completely changed colors. Right? So, unexpected color change. Right? An unexpected color change is an example of a chemical change occurring, a new substance being formed. Like I said, using food coloring is a physical change, not a chemical change. Right, so here's some examples. Right, burning wood. Right, you start off with wood, you light it on fire, it turns brown or black, right? Okay. Something else is when metal rusts. Right, you leave your bike outside, and then it rains, now it's all rusty, right? So the metal was one color, it reacted with water and oxygen in the air, and it formed rust, right? Rust is brown, or like an orangey color, right? That's a change. Right, last one we're going to put as cabbage juice. Indicator. Right, I can't explain this to you yet, right? I'll leave you hanging on this, but I will show you later in the week, right? When you mix cabbage juice with certain things, right? Like you take the lettuce cabbage, right? And you boil it in some water, right? You have cabbage juice. You mix it with different things, it actually changes color. And it is really cool to see. So I'll show you that later this week. Right, I'm going to zoom out. Make sure you have all of this. If we need to pause it, we can. All right, put this to the side, right? You're gonna need it here in a second to look back on, so I'm just gonna put it up here, right? And now I need everyone to have this paper, evidence of chemical changes. Right, you need to pause that if we need to pass it out, right? Everyone has this paper, right? It is front and back, you see both. Right, this is going to be some practice, right? So put your name at the top. HR stands for homeroom. Just put your class period, right? 2nd, 3rd, 5th, 7th, or 8th. Right, so at the top, this paper gives you some hints, right? Some things that we talked about. There's also some things that we didn't talk about, right? There are actually a couple other ways that something new can be formed, right? We talked about a change in color. Right, we talked about a gas, we talked about temperature, and we talked about a precipitate. We did not talk about a new odor being produced. Right, I want you to think about if you have ever opened the fridge and you opened a carton of milk and it had gone bad. Right, does not smell good. Right, that's like a new odor is being produced. Right, the milk was fine. Right, a chemical change happened with the bacteria in the milk, and it spoiled. Right, which made the smell of rotten milk really gross. Right, if you've never smelled that before, I hope you never have to. Right, so a smell, an odor is produced, right, and light is released. Right, those are two different ones. So light could be like a glow stick. Right, a glow stick is a chemical reaction happening in your hand. Right, you have the glow stick, you crack it, light is produced. Right, because that is two chemicals combining together to make something new. Right, so what you're going to do here is you're going to write the evidence that you see, right, on these lines from here, right? Some of them we have talked about, right? Like we just talked about food spoils and smells bad, right? Kind of like the milk, right? Well, that would be an odor is being produced, okay? So the words in bold is what you were writing. You don't have to write the whole thing, right? Like for the example, the first one is color. Right, color was in bold, right, so they wrote color, right. You're going to read each of these and put the evidence next to them, right. Also do number 10, right, we talked about this, right, in our notes. On the back, right, you have two things I want you to define at the top, right. Remember, a physical change is just changing the physical parts of something. A chemical change is making a new substance, okay? Right? This part is true or false. You can write T for true or F for false by each of these things. 3, you answer that question. Right? And number 4 down here, you are identifying things as a physical change or a chemical change. Right? So you can write physical, chemical, whatever is underneath it on the line. Right? When you finish this paper is also going to go in the back of your binder. So you should have notes first and then this paper when you are done. Right, you have the rest of class to work on this. It is up to the substitute on whether you can work by yourself or if you're going to work with a group, depending on how you've been so far. So I hope you've been listening. I hope she hasn't been having to get on to you, right, so that you can work with your table, right? But there is no getting up and going to work with a partner across the room, right? If she says you can, then you can. If not, you're not going to, right? So you have the rest of class to finish this. If you don't finish this, it's going to be your responsibility to finish this tomorrow, right? So make sure you are getting your work done, right? Thank you. She's going to be watching and writing names down, right? Be good, right? Bye, guys.